Ma, say hello. Say hello.
Hello, sir.
Give me one question paper. Okay, students, ask me your doubts. Today paper discussion. Yeah, today paper discussion, ma. $14. Okay, students, question number 14. Shown in the figure, everyone should watch. This is not a stylish doubt. If someone is asking doubt, everyone have to concentrate. And he is a good student only, na? So his doubt is yours doubt also. Okay. So shown in the figure is a circular loop of radius how much? Given small r meter, and resistance how much? Capital R. A variable magnetic field of induction how much? B is equal to B naught into e power minus 1. Sorry, I think this is minus T. Variable magnetic field means compulsory it should be T something. So I think yeah, minus 1 given. Please someone write. In question printing mistake is there. And is asking power developed right after closing the switch equal to. What a power developed formula? Response to what a power developed formula? EMF induced divided by resistance. Correct or not? You have to find the EMF induced. How will you find the EMF induced? Who will tell a formula EMF induced equal to change in magnetic flux by change in time. So pi value how much? B into area, but area of the circular cross section constant only. I will write outside that is how much? Pi r square into dV by dt. Put B value here. So that equal to how much? D by dt of how much? B naught into e power minus t. B naught I will take outside. So what do you get the EMF induced equal to? Pi into r square, and B naught is outside. What difference is now? E power minus t? E power minus t, and again beside you have to differentiate minus t. That is a rule. So if you simplify EMF induced how much? Pi into r square and B naught into e power minus t and minus 1. Substitute this E value nicely here. You get the power induced or power dissipated how much? E power 2. E power 2 means what? Pi square. Pi square how much? R power 4 B naught square and e power minus 2 into t divided by resistance is capital R. This is your answer. Then how it will be a time varying magnetic field? Okay, this discussion is waste of time, huh? Because we should not waste our valuable time in our lifetime on this kind of questions. Okay, I will object this question. Discussion also waste of time, because one wrong question. Just I hear my motto how to tackle this problem. That's all. Again, extra discussion is waste. Understood? Next problem. I will object this. Next. Next. (18) Question number 18. What is the self-inductance of a solenoid of length? What the length of the solenoid is given? L equal to. Which question do you ask this? 18, huh? Okay. 31.4 centimeter, and in meter 0.314 meter I can write. And what is the area of cross section? Area of cross section equal to 10 power minus 3 meter square is given. And total number of turns how much? 10 power 3 means 1000. Is asking coefficient of self-inductance. This is a direct formula based question. What is the coefficient of self-inductance of the self-inductor? Mu naught n square A into length. But in the place of turn density, capital N is given, length is given. Substitute, what do you get? Mu naught capital N by L whole power 2 into A into L. So the coefficient of self-inductance how much? Mu naught into N square by L square into A into L. LL cancels out, so we have to substitute. Mu naught value how much? 4 pi into 10 power minus 7 into number of turns how much? 1000. And whole power 2 divided by length is given 0.314 and into area of cross section 10 power minus 3. So here 10 power minus 3, here minus 3 will come, so it will become 10 power minus 10, and 10 power 3 whole power 2 means what? 10 power 6, 6 minus 10 means what? Very good, 10 power minus 4. Yeah, correct. I am coming to that point only. I will multiply with 10 and here I will divide with 10. So 10 into this one will become 3.14. 3.14. This 3.14 cancels out. So 4 into 10 power minus 3 Henry. Option 1 is the perfect answer for the question. Next. Twenty-nine. Question number 29, students. Question number 29. A coil in the shape of an equilateral triangle of side length is given how much? Length of each side is 0.02 meter. Is suspended from the vertex such that it is hanging in a vertical plane between the pole pieces of a permanent magnet, producing a uniform magnetic field. So that equilateral triangle suspended like this. And it is placed in the two permanent poles. Understood? And what is the uniform magnetic field? B is equal to 5 into 10 power minus 2 Tesla. And if a current of 0.1 ampere passed through the coil, what is the total couple acting in the coil? How much is asked? How much current is flowing? 0.1 ampere. As per the data, uniform magnetic field, pieces of permanent magnet producing uniform magnetic field like this. I mean, magnetic field is going into the plane of the board. In fact, the aerial vector drawn to the coil also going into plane of the coil. Understood? So, what a torque acting on that coil formula? M into B into sine of 0. Sine 0 means what? 0 is your answer. So, there is no torque acting on the coil. None of these. Option 1 wrong, 2 wrong, 3 wrong, 4 wrong. What are the keys given? Key check. No phone. Anyway, none of these only, na? Torque is 0 means 0 answer is not there. So option 4 only the correct answer. Next.
28.
Or else, student, question number 29, one more probability also there. He did not give the orientation. It may be like this also, no? The aerial vector may be perpendicular to magnetic field also, no? Yes or no? He did not give the data clearly. So we have to assume like this also. I mean, the direction of the moment may be perpendicular to magnetic field also. Or direction of the magnetic moment also may be same as magnetic field. In this orientation, torque will be compulsory 0. But here torque will be maximum. So tell me, what is the maximum torque equal to? M into B into sine of 90. What is the magnetic moment of that coil? I into area and into magnetic field. As per the data, what the current is given? Current is given 0.1. And what is the area of the equilateral triangle, strength? Side is given, na? Area of the triangle formula how much? Half base into height. Or root 3 by 4 a square also is there, na? Length of the each side is root 3 by 4 into e square also correct. If you have direct, so root 3 by 4 into a power 2 also correct. What is the a value? Length of the each side? 0.02 whole power 2. And what is the magnetic field? 5 into 10 power minus 2. 0.02, what I can write here? 2 by 100 I can write. 2 by 100 whole square means what? 4 by 10 power 4 I can write. Sorry, thank you for correcting me. Then 0.1 means what? 1 by 10 only, na? Then what will 10 power minus 1 minus 4 minus 2. Here 4 cancels out. So how much? 5 root 3 into 10 power minus 7 Newton into meter. Then option 1 correct. He did not specify the angle, na? So here option 1 only the correct answer. Okay. Many probabilities are there. See how much variation is there. Root 3 by 5 is not possible. Definitely none of this is correct, incorrect, na? Why? Because 1 is coming correct only. 10 power minus 7 is there, but anyway root 3 by 5 is not possible. Root 3 by 5 means sin theta will never be less than 1, na? Option 2, 10 power minus 10. The power gone, 10 power minus 10. Whatever angle if you take, 10 power minus 7 to 10 power minus 10, it will not go. Are you understanding? So option 1 only the right answer. Next one. 28. Question number 28. A rectangular coil of length how many meter? L is given 0.2 meter and width equal to how much? Width equal to 0.1 meter. Having how many number of turns? 50 number of turns are there. Suspended vertically in the uniform magnetic field strength. What is magnetic field strength equal to? 0.2 Tesla. And the coil carrying how many amperes of current? 2 amperes of current. If the plane of the coil inclined at an angle 30 degrees with the direction of the field. This is the plane of the coil with the magnetic field. How much angle it is tilted? Angle between the plane of the coil and the direction of the magnetic field, how many degrees? 30 degrees. Then he's asking torque required to keep the coil in the stable equilibrium. How much torque acting on the coil here, students? If you drop any perpendicular line, this is the direction of the magnetic moment, no? Correct or not? So this will be drawing here. This is the direction of the magnetic moment. Now you people respond. What is the angle between direction of the magnetic field and magnetic moment? 60 degrees. Right now it is experiencing clockwise torque. To keep it in equilibrium, you have to apply anti-clockwise and equal amount of torque you have to apply. So how much torque I have to apply here? Torque equal to M into B into sine of 60 I have to apply. Many students in the exam hall, they will write 30 degrees, 90% above students. Understood? So you can cross check yourself whether you have done or not. What the how much formula? N into I into A into B into root 3 by 2. Number of turns, how many? 50. How much current is flowing? 2 ampere. What area of the rectangle? Length into width means 2 by 100. What? How sin 60? The plane of the coil with magnetic field given 30 degrees. Read the question. Then if you drop one perpendicular line, that is representing magnetic moment. Here I will draw parallel to the direction of the magnetic moment. So angle between magnetic moment and magnetic field is 60 degrees. MB sin theta means shortest angle between M and B. Okay. So what a magnetic field is given? 0.2 Tesla and root 3 by 2 here. 2 cancels out. 0 cancels out. 0.2 means what? 2 by 10. 5 2s are 10. This 10, this 10, khatam. So how much? 0.2 into root 3 is your answer. Which question, Ray, you asked me? 28. So options are given decimal. So 0.2 into how much? Root 3 means 1.7. I will take. So 34 by 100. 0.34. Nearest answer. 0.34. Where? Any calculation mistake? If you then once I will check with the sin 30 also. Sin 30 means theta I will check with the 30 degree. So what do you get? this option is not there means I am going for 30 degrees. This is also a kind of strategy, friend. Are you understanding? Okay, you have to understand. So n into how much? I into a into b into sin 30. Sin 30 means what? 1 by 2. And n value how much? 50. I value 2 into, and area value how much? 2 by 100. B value 0.2 means 2 by 10 and into 1 by 2. So 2 is getting cancelled out. 0 cancels out. 5 2s are 10 and this 10 also will be cancelled out. So 0.2. 1 wrong, 2 wrong, 3 is the right answer. He did not hear the strategy of the question setter. He did not give angle clearly. So 2 probabilities you have to verify. Correct one answer you have to check. We proved first one is wrong, na? Answer we did not get means angle is definitely not 60 degree. Definitely it is a 30 degree. Okay. Next. Next, which question? 27. Question number 27, student. A coil of how many number of turns? N equal to 1200 number of turns. And what a mean area? 500 centimeter square. 500 into centimeter means 10 power minus 2 whole power 2 means 10 power minus 4 meter square. So that is how much? 5 into 10 power minus 2 meter square. And the area is held perpendicular to coil is held perpendicular to magnetic field means this is a coil held perpendicular means like this it is oriented. Okay. And what the magnetic field is given? 4 into 10 raised to minus 4 Tesla. And the resistance also given how many ohms? 20 ohm. When the coil is rotated by how many degree? 180 degree. Means this is the first orientation. Aerial vector is like this. In second orientation, aerial vector will go downside. Please say yes or no. In how many seconds he rotated? 0.1 second, and is asking electric current in milliampere. First of all, what is the electric current formula? EMF induced by resistance. What EMF induced is nothing but final flux minus initial flux divided by time taken into resistance. What is final flux? Minus NBA. Why I have tried minus NBA? No, your method means B into N into B into A into cosine 180. Angle between B and A is 180. But I skipped one step, minus 1 directly I am writing. And minus, what is initial flux? N into B into A into cosine of 0. So that is how much? N into B into A divided by what is time taken? 0.1 second into 20. So what is the total current induced here? This one into this one, how much? Minus negative sign. I do not care. I already told you. I have the confidence in judging direction. So negative sign I don't want. N into B into A divided by 0.1 into 20. Number of turns 1200. Magnetic field how much? 4 into 10 power minus 4. And what is the area of cross section? 5 into 10 power minus 2 divided by 0.1 into 20. Okay, how we should do? 0, 0 cancels out. This two cancels out. 0.1 means 1 by 10. 10 will go upside. 2 zeros means here plus 2 will come like this. And 10 power minus 2 will come like this. 2 minus 2 will become 0. 4 5s are how much? 20. How much this is? 240 into 10 power minus 4. So 24 milliampere is our answer. Which is the right answer? 24. Option 2 is the right answer. Next. 33. 33. Someone said 33. I will start 33. Question number 33. When a proton releases from rest in a room, it starts with an initial acceleration. What is that? Proton is T and acceleration how much? Towards west. Assume here this surface of the board as a surface of the ground. How many directions we have? We are watching from a stationary helicopter. So this is what? East and west, north and south. In which direction it is starting acceleration? Towards west. It is going like this. It is going with an acceleration a0 like this. And when it is projected north, when it is projected towards north with what speed? V0. And moves with an acceleration 3a0 towards west. Then the electric and magnetic fields in the room, how much? With what speed he projected? Here is the case number 1. Students, case number 1. Case number 1. The proton started from rest. Means initial speed how much? U is equal to 0. So it has only acceleration in the west direction. Understood? So I can write net acceleration direction. What I can write? A0 into minus I cap. So I will treat plus x, minus x, plus y and minus y. Understood? So it is going in the west direction only. If it is in the rest means definitely this side compulsory positive charge plate is there. Definitely this side is negative charged plate is there. Correct or not? Then only it can accelerate left side. Why? Because it starts from rest only, na? Say yes or no? It has constant acceleration means definitely it will have the constant force. Constant force means constant field also. So what is the direction of the electric field here? Definitely towards west only, na? Say yes or no? So what is the electric field here? Electric field definitely electric force by charge. What electric force acting on it? Mass into acceleration by charge and into west only, na? Correct or not? So you have got one partial answer. Understood? You have got one partial answer. Definitely it is option 1 or option 2. Option 3 wrong. Why? Because east is there. Electric field is east. It is no possibilities there. And 4 also no possibilities there, na? So fourth also we can eliminate. Now by analyzing the second situation, you have to judge the magnetic field upside or downside, or we have to judge. Now when it is projected towards north with a speed v naught, this time this positive charge is projected with what speed? V naught side it is projected with an initial acceleration towards west. Here initial acceleration how much? 3a naught, and it is a west side. So acceleration perpendicular to velocity of projection means acceleration this side means undoubtedly force also this direction, na? Which force is perpendicular to velocity? Magnetic force only, na? If you have doubt, check the magnetic force equation. How much? Q into V vector cross B vector. B is perpendicular to V is also perpendicular to force. Undoubtedly, undisputedly, that is the force due to magnetic field only. Now you people respond in which direction magnetic field will be acting. Respond. Force is left side, velocity is like this. Direction of the force, direction of V cross B same only, na? Stretch your fingers along V. If you assume B is upside, curl your fingers from B to B. If you do so, force is going like this. So magnetic field is not coming out of the board. Out of the board means above the ground, means upside of the ground. Upside is wrong only. Upside is wrong means which side is correct? Downside. V2 magnetic field is into the board means into the well, into the ground. So magnetic force is left side. So what is the correct answer? Magnetic field should be which direction? Down direction. Which is the right option? 2 only the correct answer. How to find magnitude? Is asking magnetic field. So force equal to how much? Q into V into B into sin 90 only, na? So magnetic field equal to how much? F by Q into V. F value how much? 3 m into a naught. Mass into 3 into a naught acceleration. And divided by how much? Q into V naught. Yes or no? So which is the right option? Three is not there, na? But we have to get the answer 3. Okay. Here already one acceleration is there, na? That is a naught is there. Means 2a naught if you take means upside you have to take. Option 2 wrong. Here already electric field is there, na friends? Here some logic alone you have to use. If you assume the magnetic field is into the paper, I mean down the ground, already acceleration due to electric field A naught is there. Now freshly acceleration due to magnetic field also there na. So 3A naught plus A naught how much? 4A naught. So 4A naught not there. Then definitely to make 2A naught, definitely this 3A naught should be this side only na. Correct or not? I mean that magnetic field is, you can't do this. Are understanding? You can't do this. So what we can write? Magnetic field will be coming upside. Yes or no? He used 3A naught towards west, but it may be negative also, no? Retardation also, no? Correct or not? Very simple. This is the 3A naught means compulsory this acceleration should be, sir, this A naught means 3A naught should be right side only, no? Means magnetic field is not downside. Magnetic field is upside. I mean, what we assume direction is wrong only. I mean, reverse it will happen. Then only the acceleration will become 2A naught. Yes or no? Correct or wrong? Understood. So which is the right option? Option 1 only the right answer. Key 2. If key 2 means down means compulsory 3 should be happening. Okay, once I will check it. From my end also any corrections I will check once. Okay, next question. Next one. Students, question number 35. Am I right? Question number 33 also one in that. Question number 35. A rectangular loop carrying a current how many ampere? I ampere, situated near a long straight wire such that wire is parallel to one of the sides of the loop and it is in the plane of the loop. If a steady current I is established in the wire as shown in the figure, then the loop will be option 1, rotate about an axis parallel to the wire, move away from the wire and move towards the wire and remains stationary. So here stationary current is flowing and here also, sir, this is capital I, this is capital I, and here also current is going in which direction? Ma, please listen carefully. I told many times his doubt is your doubt only. Okay. So tell me, both are steady current means due to this current carrying wire, infinity current carrying wire, here magnetic field is going into the plane of the paper only, no? By using right hand thumb rule, keep your thumb in the direction of the current, bring the fingers here, so magnetic field is going into the plane of the paper only. But initially here magnetic field is more, but as you are going right side, magnetic field is getting reduced. Agreed or disagreed? Yes or no? Means in this segment, on the first segment, what is the direction of the magnetic force acting on the first segment? I into L cross B. L towards B. Length direction, current direction, both are same only. L towards B. And so in this first segment, magnetic force is maximum. That's what I have drawn a somewhat long vector, magnetic force. On the second segment, I check it. What is the direction of the magnetic force? L towards B, but very less, na? Say yes or no. And here, magnetic force in which direction? L towards B. I will take one small element here. Here, how much force is acting? This side also, equal and opposite forces are acting, na? Yes or no? Like this, the scenario, the forces will be descending order and they are equal and opposite. Agreed or disagreed? Everyone agreed, no? Means you don't need to consider these all forces are nullified by these all forces. Because they are equal and opposite. So only which are significant forces? This is significant, this is significant. Moreover, these forces are all are acting in the straight line. Any forces are acting on the straight line. Do you provide any torque or can you rotate? This is one door. I am pulling this side, you are pulling that side. We are pulling on the same straight line. Can you rotate the door? Can you rotate? Can you apply torque? You cannot. So here rotation is not possible. If you want to rotate, you have to apply the force like this, you have to apply the force like this. So it will rotate in the anti-clockwise. This paper is there, na? See, my two hands I am pulling like this. Can you rotate? Can you apply torque? Means two forces are acting on the straight line. Do not apply any torque. If I want to rotate the paper, what I have to do? See, these two forces should not reside in the one straight line. Is my point clear, everyone? Yes or no? So tell me suitable answer. Rotate about option 1 wrong, na? Is saying rotate about an axis parallel to the wire. Do you support? Wrong, na? Just now you accepted, no? Option 2 moves away from the wire. Is it possible? Huh? No. Is there any sense? No. Why? Net force is moving left side, so it will displace towards the wire. So 2 also wrong. So 3 is the right answer. Remain stationary is wrong. I hope everyone understood. Next. Next, student. $39. Here, question number 39. A circular current carrying coil has a radius how much? Capital R. The distance from the center of the coil on the axis where magnetic field equal to how much? 1/8 of the value at the magnetic field due to its center. This is a coil. Let's say at a distance x meter. Please someone tell me what is the magnetic field at this point? Mu naught. Very good. I into capital R square by 2 into very good R square plus x square and whole power 3 by 2. If n number of turns are there, you have to put n. This is a magnetic field at this axial point. That is exactly equal to how much? 1/8 of the magnetic field at center. Someone tell me what a magnetic field at the center? By 2 into R. Mu naught. I cancels. So 2 ones are how much? 2 fours are, or 4 twos are how much? 8 here. This R cube r into r square r cube. Correct? This 8 also I will send here. This thing I will bring here. So r square plus x square and whole power 3 by 2. Very good. 1 by 2 and whole power 3 I can write now. 8r means what I can write? 2r whole cube I can write now. All are you understanding now? Cube cancels out. Now I will do it square. What I will do? Square I will do. Now 2 also cancels out. Understood? So here left side what? 4r square equal to how much? R square plus x square. R square I am sending this side. So what do you get? 3r square equal to x square. So x equal to how much? R root 3 is your answer. Which question you said, right? So option 2 is the perfect answer for the question. Next. Next, 42. Question number 42 here. A current how many ampere? Given current equal to I ampere flows in the loop having a circular arc of radius how much? Small r meter. Subtending an angle how many degree? Sorry, how many radian? Theta. When theta isolatedly given, that is radian, not degree. Remember, as shown in the figure. And magnetic field at the center O of the circle, how much is asking? Any twist is there here? No twist. It is a direct straight formula, I think. What a magnetic field due to arc shaped wire formula? B equal to how much? Mu naught by 4 pi into I by R into angle subtended. So which is the right option? First option only, na? That's all. Key correct, huh? Next. You said bro, na? Bro, how many marks? Physics. Online, offline? Why? College exams are important, right? Next. How much? 40? 43. "43. In the figure, there are two semicircles of radius how much? R1 and R2. In which how much current is flowing? I ampere is flowing. Then magnetic field at the center O will be how much he is asking. This is one large semicircle. How much current? I ampere. This is one more finite wire. This is the semicircle. Here how much current is going? Like this. Its radius is how much? R1, and this radius is how much? R2. Here totally how many segments are there, friends? First segment, this is the second segment, this is the third segment, and fourth segment. Here you have to use the vector addition principle. But net magnetic field at the center, B1 plus, B2 plus, B3 plus, B4. Do you think 1 and 3 themselves producing any field? No. Why? This center residing on the own body, so themselves they do not produce any magnetic field. So B1 0 and B3 is 0. But a magnetic field due to second wire, mu naught by 4 pi into I by R1, arc shaped wire formula. What is the angle subtended? 180 degree. Here angle subtended by this 180. Direction is important. You have to use right hand thumb rule. Keep your thumb in the direction of the current. Bring the fingers at the center. They are inside the screen, into the screen. So minus K cap or minus also you can write, no issue. And what is the magnetic field due to this one also? Minus only, na? If you have doubt, check. Keep your thumb in the direction of the current. Bring the fingers into the screen. So that how much minus or plus? Minus. What a magnetic field due to the arc shaped wire? Minus mu naught by 4 pi into I by R2 into pi into K cap. K cap is not required. Why? Because same direction means unit vector is not required. So shall I multiply with 2? So you can't. Yeah. Mu naught. Yeah, minus mu naught I by pi and pi again cancels out. So how much? R1 plus R2 by R1 R2. Understood? It's the right option. This step understood, everyone struck. I keep the LCM directly. 1 by R1 plus 1 by R2 directly you can write like that. Next one. Which is the right option? Option 3. Next. Time over. Then why are you watching? Next. No. I like to sweat. Wantedly I am sweating. I like this cooling sensation is good, so I am doing. No. Tell me. I am torturing you, right? No. Okay, tell me. Okay, tell me. Next question. Palagicha. What is? Okay. Next ma 46. Question number 46. Electron of mass is given. What is the mass of the electron? 9 into 10 power minus 31 kilogram. Under the action of magnetic field, moves in a circle of radius how much? What radius of the circle? 2 centimeter means 2 into how much? 10 power minus 2 meter. With a speed what? 3 into 10 power 6 meters per second is given. Then a proton of mass also given. 1.8 into 10 power minus 27 kg. What to move in a circle with same radius in the same magnetic field also. Then its speed equal. Tell me someone what radius of the circular path formula, friends? M into V into Q divided by B, no? As per the data, first situation will give one equation, second situation will give one equation. I will divide, I will try. Okay. R value how much? 2 centimeter equal to mass of the electron how much? 9 into 10 power minus 31 into V value how much? 3 into 10 power 6 divided by charge of the electron. I will write E, magnetic field. I will write B. This is equation number 1. For second situation, now I will convert into equation. Radius also again 2, na? Correct or not? Charge is, mass is given how much? 10 power minus 2, 10 power minus 2 will be cancelled out. Okay. So 1.8 into 10 power minus 27 and into V value how much? That is only our target. What is charge of the electron? E. Charge of the electron, charge of the proton, both are same only, na? So magnetic field is same. Nicely do calculation 2 to Katam. EV Katam. I will bring this term that side. So 1.8 into 10 power minus 27 into B is equal to how much? 27 into 10 power 6 minus 31, how much? 25. This one I am bringing this side. 27. This is what? 8 by 18 by 10. Na? 10 will come this side. 28 minus 25 means what? 28 minus 25, how much? 3. 9 2s are, 9 3s are. So V value how much? 3 by 2 into. Have to see the options. Option 2, yes. 1.5 into 10 power 3 meters per second is the correct answer. Option 2. Okay, everyone understood now? Next. $49. Question number 49. A proton and an alpha particle accelerator. This side, I'll write proton. This side, alpha particle. Two situation means two equations will come. Accelerated through the same potential drop means here how much potential drop is there? Here also same potential drop will come and entered into same magnetic field they are entering, B and B. And if the radius of the proton circular path, what radius is given for proton? 10 centimeter. You have to find the radius of the alpha particle. Here they came out of the same potential drop, na? How will you create a same potential drop? Take one capacitor plate. This is one positive charge. This is one negative charge. You kept one positive charged particle. When it is arrived at this point, what will happen? Speed will increase now. I can write one statement. Increase in kinetic energy equal to decrease in potential energy. What is increase in kinetic energy? Half mv square. What is decrease in potential energy? Q into delta V. What is speed of the each and every charge? V is equal to how much? Under root of directly I am writing 2 into Q into delta V divided by mass. You people respond, what is the mass of the proton? each proton, each neutron, I will write m kilogram. So what is the mass of the alpha particle? Please respond. What is the mass of the alpha particle? Alpha particle means helium nucleus. Inside the helium nucleus, 2 protons, 2 neutrons are there. Total mass how much? 4m. What is charge of the proton? Plus C. What is charge of the alpha particle? Very good, plus 2e. Why? Because 2 protons are there. Now we know radius of the circular path how much? mv by qb. 2 situations are there, 2 equations are there. Divide them, you will get the answer. What radius of the proton? 10 centimeter equal to what is the mass of the proton? M. What is the velocity of the proton? How much? Under root of 2 into what is charge of the proton? E, and same potential drop delta V divided by what is mass of the proton? M. M into V divided by Q. What is charge of the proton? E into B. And whole divided by what radius of the alpha particle? That only our question. So I will write what is the mass of the alpha particle, my dear students? 4m. And under root of velocity how much? 2 into charge. What is charge of the alpha particle? What is charge of the alpha particle? 2 into E. And potential drop? Huh? See, I am also a human being. I am not a god. If I am writing mistake, please correct me. Understood? Okay. Tell me what is this? Where I am 2q into delta V by mass. What is mass of the alpha particle? 4m divided by and whole divided by what is charge of the alpha particle? Very good, 2e and into B. Now I have to divide. BE cancels, M cancels, EE cancels, delta V, this 2, this M cancels out. These 2's are, here 2's are, and here under root of 2 by 4 means what? 1 by 2, so it is root 2 only. Correct or not? So I can write 10 by r equal to how much? 1 divided by 2 by root 2. So radius equal to how much? 20 by root 2 is our answer. Again you have to simplify. Root 2 into root 2 you have to multiply. So radius equal to how much? 20 root 2 by 2. So 10 root 2. 10 into 1.4. So 14 centimeter is your answer. Option 2 is the correct answer. Everyone understood now? Okay. Any more questions? Okay. Now take break. Once give me that note, ma. Okay, students. Thank you. I will give. I will take my I have question.
Thank you.